This video is a walkthrough of the Using SQLite in Python booklet. I will be working through the booklet step by step and showing you what my REPL looks like at each point. Because I am showing the booklet side by side with the code, you should be able to skip ahead to any part that you're stuck on. So here we go. Starting with page 1, creating the connection. I need a new REPL in Repl.it. I am writing in Python. Although we're going to be dealing with SQL, SQL, I am going to be writing this in Python. The whole point of this booklet is to show you how to access database using Python. So we're using Python. I'm going to call mine Play with SQL. You can call yours anything at all. It probably isn't good practice for me to put spaces in my name, so I'm going to replace those with underscores. You can call yours whatever makes sense to you. Okay, I'm going to create the REPL. Okay, so there is a main.py file. Main.py. I'm probably not going to show that unless I need to. And then I have a code window, and then I have a terminal, or the thing that lets me see output and error messages and things like that. So the first thing I'm going to do is connect to a database. And I don't actually have a database yet, but handily, when I make a new connection, if the database doesn't already exist, it will create the database for me. And this works with files as well. If you try and connect to a file that doesn't exist, it will create the file for you. So we need to import the module SQLite3, and then we need to make a connection. So this line here is making a connection to the database. And con is just me picking a variable name that is short for connection, because typing connection over and over and over is really long. Okay, so I'm going to run that code. And you'll notice that over in my files window, I have a new file called mydatabase.db. So it doesn't have anything in it just yet. It's just blank. But you can see that it exists. And it exists because I tried to connect to it. If I was using my code offline, it would look more like this. So I could save it into my folder and it would create this mydatabase.db. Okay. So I'm just going to add one extra line under this. Now this is called a cursor. SQLite cursor is a way to do things with your connection. So you've connected to the database, but you can't actually do anything with it unless you have a helper that's going to have execute functions, and we're going to use this a lot. You don't actually have to understand cursor in detail, but it does really help for you to, you must have this line here. This is a trust me, have this line thing. Trust me, you need this line. Okay, so we're going to put in curse, and I'm just being shorthand again. Curse equals con.cursor. So for the connection that we've already made, you need to use the cursor function, and the thing that it returns is going to be called CURS. So now that we have a cursor, we can execute SQL. And I could select, I could execute a select statement if there was any data in this database at all. At the moment, there isn't any data in the database, so what I need to do is put some data in the database so we can go and check what's in there. Okay, so to do that, we need to create a table, and most people have done this already. So I'm just going to copy this code entirely and all of the comments, because the comments are useful. and I'm going to paste it in here. So we import the library, we connect to the database file, we make the cursor, we then execute this magical SQL code here. Create table animals, animal ID, integer primary key, auto increment, scientific name, common name, diet, habitat. And this whole section here isn't strictly necessary, but does make your life easier. So everything in a table should have a unique identifier, something that allows you to make sure that there are no duplicates. And so this is just asking the SQLite to make that unique for us. By using auto increment, it means the first one is going to be number 1, and then the second one is going to be number 2, and etc. So if we have hundreds of things in the database, we can always make sure that we're looking at one unique one because it has a unique ID. And then this means take all of the stuff that you've just done and make it saved. It's kind of like our save function. Make it true. That's called commit. And then finally, it's good practice to close the connection. Generally speaking, when the code stops running, it will close the connection, but it's always just good practice to close a file that you're working on and to close a connection that you're working on. So this creates the table called animals. Run that, and it comes up and doesn't tell me anything at all, which isn't very useful. So when I make a change, I'm going to put a print statement in to at least tell me that it's done something. So this next part of the booklet says go to DB Browser Lite. I've got DB Browser Lite. Not everybody does. And I don't think anybody does on their surfaces yet, but we're hoping that it will come soon. So this is what DB Browser Lite looks like. And I can open a database in here to have a look at what's going on. So in order to do that, I need to download that data, and I do that here. Now, unfortunately, there's no nice way for you to just browse the database from the internet. If I was running my code in a file, in a folder on my computer, I could absolutely browse regularly and add stuff to my data. But at the moment, because we have one thing in the internet and one thing on our computer, you can't get them to talk to each other. You have to do this horrible download and open process. Downloads, play with SQL, and my database. And there's my animals table. And if I go to browse data, you can see that it's there. Unfortunately, it's empty. So let's go have a play with it. Bring my Repl back, bring my booklet back, and we'll move on. Okay, I think there's an extra page there for some reason. We're going to alter the table. So you can play spot the difference. This was my create table animals code. Create table animals with animal ID, integer primary key auto increment, scientific name, common name, diet, and habitat. I want to add a new field called vertebrate and make it an integer. I can't easily add a field to a table that's already been created, so you have to be quite careful about making sure that you create your table with the right kind of data in it. So I can go and get this and run this code. And it's got the same import, the same connect, the same cursor, and the only thing that's changed is this execute. Right, so when I run it, we'll see that I get an error message. And that's okay because I was expecting to get this error message. And you can see it here. And the bit to pay attention to is that last bit that I've highlighted, which says table animals already exists. So you can't make a table when the table with the same name already exists. So what I can do is run the SQL code I know that allows me to drop that table, to get rid of a table, and then create it again with vertebrate and integer. And so when I run this, it works. And if I run it again, print table created, and it actually prints out table created for me. And the reason it didn't give me an error that second time was because I've got this drop table. So all I'm doing is dropping the table, so getting rid of it out of the database and then putting it back again. And I can run that as many times as I like. It won't do anything different. It won't add any data. If there was any data in the table, then dropping the table would mean that that data is now deleted. So I can have a look and download that code, download the database, extract that, and then go and open DB browser, open database, new one in Play with SQL 1, mydatabase.db, and you'll notice that this time it has the vertebrate field. So I've definitely made that change. Okay, going back to the booklet. Right, we now need to save that and move on. We've created this database and created a table that we're going to use, but if I just keep running this drop table, create table over and over, it's going to delete all of my data each time, and I really don't want to do that. So I'm going to make a new Python file. Just so that I can save all of that code and not have to type it all over again. Now, a better way to do this would be to make functions so that I only do the drop table thing once and then I can do the insert thing lots of times. But I don't want to make this too complex, so I'm just going to copy and paste that code into make table and clean up my main.py. So that's what the move on means. Okay, so now I'm going to insert into the table. The table still exists because my database.db still exists. Okay, in order to do that, I've just grayed out all the bits that you don't need to read every time because they're the bits that we've been using the whole time. So I'm not going to explain this top section because it does the same thing, but curse.execute this time does some quite different SQL, and this stuff that's all red is all SQL. So I can insert into the table animals with the field name, scientific name, common name, diet, habitat, vertebrate, and the reason I'm naming, I've named all of those but the first one is because the first one is that order increment. So it will just create a new number that's one more than the last number. That's how it magically works, which is useful. And the values are, I'm not sure I can read the Latin, but the scientific name for an Australian green tree frog and the common name for an Australian green tree frog, and that it's a carnivore and that it lives in the rainforest and that it's true that it is a vertebrate. So when I run that, it goes back to blank line again, which isn't very helpful. I should definitely have put a print in, but I'm going to go and download the database again, and we're going to go check that it's in there with DB browser. So give me a second. and open the browser, and then open the database, which is no longer in play with SQL1, it's now in play with SQL2. Open the database, and you'll see we have animal ID 1, scientific name, that one, common name Australian green tree frog, and it's just shrunk because it didn't quite fit, but it's still there. Diet carnivore, habitat rainforest, and vertebrate 1. 1 being the equivalent of true. Okay, we've verified that it exists. Let's go back to the booklet and let's go back to the code. Okay, so what I want to do is insert more than one row. I don't want to just insert one row. So I'm going to use this code, which is only a slight change to this code. So if you look, you can find insert into animals, scientific name, common name, diet, habitat, vertebrate here. Insert into animals, scientific name, common name, diet, habitat, vertebrate is there. And then values, I've typed them in here, but over here the values are question mark, question mark, question mark, question mark, question mark, which means hold on, you're going to be supplied with 5 variables. And then this comma row data means these are the 5 variables that I want you to insert. So this code here will get an input from the user that says scientific name, get an input from the user that says common name, get an input from the user that says diet, and store it in the variable called diet, get an input called habitat, and store it in the variable called hab. I really should have greened those, sorry about that. And then get an input for vertebrate 1 for yes and 0 for no, and convert it to an integer and put it into the variable vert. And then we've got those 5 things being joined together into a list. We've done lists. Everybody should recognize that that's what a list is. And so that's what row data is. And when you have those 5 things in row data, it gets inserted into the table. So I'm going to copy this code and we'll run it and see what happens. Okay, is that everything? So now I want to run it and see what happens. And you'll notice, I just drag this across, that the output is showing me scientific name. So I'm going to go and get one of those scientific names. As we spoke about before, don't know my Latin. Okay, that's a scientific name. Common name is Eastern Blue Tongue. Diet, omnivore. Habitat is, I need to go look at my key. Bush. Vertebrate, definitely. And then it's finished. Okay, so I'm going to slide all of this back. And we can now go and check to see if that got inserted correctly. So download a zip. In SQL3. Open database. And now I have 2 records in the database. Okay, now that we can add records to the database, and we can create a table, and we can create a database, and we can change a table, and then insert data, we're up to getting stuff out of the database. When you do your assignment, I'm expecting that you're going to have a lot more data than 2 records in your database. We can import data from somewhere on the internet. We can find a CSV and import that. Whatever is going to suit the problem that you're trying to investigate. Just like with the make table, I'm going to copy this code because I don't want to lose it. So I'm going to make a new file. I'm going to call it insert data.py, and I'm going to paste all of that in there. And then when I go back to main, because it only runs main when I press the play button, we're going to put new code here. So going and getting our select statement, we're importing SQL again, we're connecting to the database, we're making a cursor, which is just our helper. We're going to execute some SQL, which you should all recognize from the Grok course. We're going to commit it and we're going to close. And when I run that, it's not going to do what we need it to do. So we're going to have to do a couple of other things. But let's have a look. Run, nothing. It's not very helpful. But that is exactly how the syntax works. So knowing that you've got all of these bits, and it's just the same as any other execute of SQL, is good to know. And so now we just need an extra step to go and fetch that data from the cursor. So that's when we get to this bit, fetch all data. So there's a thing that says cursor.fetchAll. So I'm going to grab all of that code, which is essentially the same as the last lot of code. But the only difference is that we have these 3 lines here, which is get, all the data from the cursor. And then we have loop through the data 1 row at a time. And then print the row. Okay, so this is not going to be very pretty, but it will work. So let's run it. And you'll notice over here, it's printing each row of the table. This one goes to there, and this one goes to there. So, just like when we did our list lessons, we can actually target a piece of information that we want to get from the rows by saying that instead of printing the whole row, maybe we'd just like to print the scientific name, which is row position 2. No, it's not. It's row position 1 because we start counting from 0. So when we run that, we get the 2 scientific names. And we could even make it a little bit neater by saying row position 0, comma, row position 1, comma, row position 2, comma, row position 3, and comma, row position 4. And run that. And you'll see that it's nice and neat. We have little spaces between our fields rather than it all being in a list with commas between them. So this is the fundamental stuff that we need to, this is all of the stuff that we need in order to make our larger database. You need to be able to make a database, make a table, put some stuff in the table, and then get stuff out of the table. So this is the fundamentals. I want you to have completed this activity before we go on to playing with our website. The website that I've made that you're going to get given as your starting point, rather than us needing to do this step, this 4 row in rows, and print it out nicely, is going to pull that data into a website so that HTML tells it where to lay out, which is really useful and kind of funky. So I hope that explained this workbook a little bit more. I'm sorry that people got a bit lost, but those are the fundamental things that we need to be able to do. Create a database, create a table, put some stuff in the table, and get some stuff out of the table.